From the Library of Congress in Washington, D.C.
Hello, everyone. I think we're going to get started. I know it's a big crowd and people are still waiting to get in. I'm so flattered you've all come to see me.
I came.
I'm Joe Palca, and sitting to my left is someone, a famous book author by the name of Buzz Aldrin. And he's done some other things besides write a book, but we might talk about them or not. I'm not sure.
Eight or nine books.
8 or 9 books, sorry. But we're only going to talk about this one today because I have to confess I haven't read all the others, but I've read this one. Before we get started, though, I wanted to ask you all a question. How many people in this room want to go to Mars?
Wow.
All right. So
we don't have room for you all. Yet.
How many people do you think will be on the first mission to Mars? Oh, how much money do I pay?
Yeah.
Okay.
No.
No, you mean how much is it going to cost?
How much does the government pay?
I see. So, but realistically, if you were going to ask the government for money, would you ask them for money for a small mission, 1 or 2 people? Or would you ask them for money for 20 or 30 people?
Over and over and over again. It's more. I wrote a book, and National Geographic got the title, Mission to Mars. And I said, can't you put an S on the end of that? Missions. We're not just going to go there once. We're going to go many, many times. And
so why haven't we been yet? Or is it back to the money?
There are steps. And after the moon, there were some things we could have done at the moon, and we had a really good rocket.
Which was that?
Saturn V. Technology maybe was catching up a little bit. There were other basic principles. The Russians had a rocket with sides.
Oh yeah, with these boosters on the side.
Parallel burn. We had a rocket that was series burn. Frankly, parallel burn with boosters on the side is better.
Yeah. And
that's what NASA is looking at now. They modified things from the shuttle.
So is there a rocket now that could send a capsule, even a Apollo-sized capsule, to Mars, or do we need to build a bigger rocket?
We need a bigger, and NASA is building a bigger, and because of the Columbia accident in '03, we decided that the shuttle, we had to replace it, and we had to do some more exploration. So there was a plan to build a way to get people in and a way to get other things in. And it didn't work so well.
Yeah. So how long is it going to take? The trip to the moon was a couple days, 3 days. It's going to be a long trip to Mars. What are people going to do? I mean, there's not much movie theaters on the way or entertainment.
Well, how long is it going to take?
Well, how long is it going to take?
I thought you were going to ask me.
Oh. Does anybody want to know how long it's going to take?
Now, wait.
Yes.
There is a minimum fuel. It's a little sensitive. And that's about 9 months.
9 months.
See, the sun, Mars, Earth. Now, Earth catches up with Mars. That's a good time to go. But what happens after that?
You got to go.
The Earth goes around twice. Mars goes around once and a little more, 26 months. 2 years and 2 months. That's the time when it's good minimum fuel, short time to go Earth to Mars and Mars to Earth. But to go in between those times is much more difficult, takes longer time, takes a lot more fuel.
So when
It wasn't that way at the moon. You could go almost any time you want.
yeah. When astronauts get there, won't they be like their muscles have like gotten weak from being in low gravity for so many months, and they're going to land on this planet and they're going to be all wobbly because you see people
No.
come back to Earth and they're not moving so good.
Well, they're going to be launched from Earth gravity, and I don't think more than a month, maybe a couple of weeks here in orbit before they leave on 5 or 6 months en route. And at least that's the cycling spaceship that can get there.
Okay.
And schematically, it circles around the Earth, and the Earth gravity directs it. Just swings by at the right, and off it goes to Mars.
Cool.
When Mars gets there, it swings by Mars. And then through some clever engineering, lo and behold, it comes back to Earth again.
That's cool.
Now, that's okay, but it's got to come back at just the right time, just the right angle.
Right.
Guess who figured that out?
Kepler.
Nah. Me,
Wow. That's pretty
1985.
cool. Why were you
Now,
thinking
why did
about
it
this?
take so
Yeah.
long?
Huh?
We went to the moon in a orbit that went around at a figure 8. What was that? It was a free return. So if something went wrong going out, we would swing around and we'd come back to the Earth. That's good news, right?
Yeah, sure.
That's smart thinking.
Yeah.
Yeah.
So it would work that way for Mars
took
too.
3.5 days to
Uh-huh.
get there.
Got it. Got it.
Now, I figured out that you can swing by the Earth again and then go out. Moon isn't there. But that's all right. It's going to come back. So I can go out a couple of times. So I was working on a cycler between Earth and the moon.
I got it.
NASA did not think it was a good idea because they wanted a better way to put somebody from the surface of the Earth to the surface of the moon. Now, we already had a great way to do that. A very clever engineer figured that out in 1962, and it was called Lunar Orbit Rendezvous. We could go there and land and leave a ship in orbit and then lift off, join up, rendezvous with that ship, and come back and leave the lander there. It was very, very efficient. And nobody's going to figure a better way to go from the surface of the Earth to the surface of Mars. I mean, the moon. The moon.
Yeah.
They both begin with M, and I get confused.
Yeah, no, that's okay.
And I confuse a lot of people.
So
But now,
no, I was just going to ask you, once you get there, it's going to be a hostile environment. I mean, you can't just go out like we're dressed today. Well, there's not going to be shooting at us. That's true. Nobody, little green men.
no little green man.
No little green women. Forgive me.
You sure
but-
about that?
I'm told. But how are people going to move around outside on Mars? Isn't that kind of a problem? I mean, you have to have a spacesuit, and it's big and uncomfortable.
Well, let's look at it. To land, you got to slow down parachutes and drag devices, and then the air. There is no air, but it's very thin, so you got to use a rocket to land, and that gives you a cabin for the people and a propulsion system. You're going to land, and you're in a cabin. That's not where you're going to live. Okay? Because we've already landed a number of much bigger cabins and connected them all together. Now, at the moon first, Mars.
Oh, so you want to practice?
We
Practice putting these together someplace before you send them all up to Mars.
Big island of Hawaii, 9,000 feet. That's where we're going to practice.
Really?
Yeah,
Up
with
on-
a little delayed communication and see how it works. Probably won't work, but we'll fix it. We'll do the fixing.
Yeah, so,
Just a little bit of fixing.
so this is like Mauna Kea, Mauna Loa, those two volcanoes up there?
Well, we're not going to hook the mountains.
No, that would be very tricky. That would be very tricky. So, do these things hook together by themselves, or do you have to send up people to hook them together and then bring them back?
Labor is very expensive up there, and kind of dangerous. We can do things by telling a robot what to do, and we do that on Mars, and we do that on the Earth. But you tell a robot to do something on the Earth, and the robot hears you right away. Less than a second. Now you tell a robot at the moon to do something. He doesn't hear it right away. Because radio waves travel at the same speed as light. Light travels pretty fast. But it takes a second and a half to go to the moon. So you're back here, you tell something on the moon to do something. Okay, second and a half later, it hears, starts to do something. But you don't know how well he's doing until a second and a half after he's done it. Well, he may have gone off the cliff by then. So it's very conservative.
Yeah.
Okay, whatever it is, it'll work. But we got to practice it.
Okay.
Now, Mars, the closest that Mars, or the Earth is to Mars, 4 minutes away.
That's the closest, because sometimes
Yeah.
it's further away
That's
even
when
than
the
that.
sun is here, and Earth and Mars at the same time. Tell us, say the Earth's over here. 20 minutes. There, 20 minutes back. You know, you can go out and have lunch.
Well, I was just going to say, it's the perfect excuse for being late to a meeting. I thought that meeting happened 20
Reschedule.
minutes ago. You could miss it altogether. So go ahead.
No, but what does that mean? Now, the guy who does this can tell you what it means. Because we, 11 years ago, landed a rover on both sides of Mars. They were supposed to last 90 days. One of them got stuck 5 years. Spirit was its name. The other one, Opportunity, is still working.
It's amazing.
11 years.
It's amazing. Have everybody
So-
seen pictures that they've taken of Mars? And there's another one there. Who knows the name of the other one?
Curiosity.
You know? Curiosity. That's great. Okay.
Now, so we understand the person back here who's in charge of those sending messages, just to help people. He knew what it meant and how difficult, but just to let other people know. He looked at what both of these guys did, robots, in 5 years. And he said, if we had a human being with intelligence, he has to be intelligent, he has to be smart to even get there. But now he has intelligence, and it's a second, less than a second to these robots. What it took these guys 5 years could be done in 1 week.
Yeah.
That is big news. So if we want to do anything on Mars, we better get there close to do the intricate things Now, from Earth, we can land things and slowly put them together. We can put people in orbit, but their time is very valuable. So from Earth, we can bring things pretty close together, but not the real intricate. We got to get people to Mars in orbit. I can't ask a question. How many moons does Mars have?
How many moons? Who says one?
Two.
That's right, 2.
Small little bitty things.
I think somebody put those there. You know, people thought that.
No. Most of the thinking is that they were maybe asteroids.
Yeah, that got captured.
Maybe a moon. Oh, forget about the
Okay.
moon. They're closer, much closer than our moon is. They're much, much smaller. And a lot of people have been thinking that we could use those as a place to hold. Gravity's very small, but we could live there. And now, what could we do with antennas? We could control things on the surface. So Earth gets them close together, and then we get people up there. We'd be wasting their time. But now, if they put enough of them together, they get to maybe land. Now, if they land at the end of 26 months, oh man, we got a bunch of other guys coming in. Now, people have been talking about landers.
Uh-oh. Here's
Buzz, don't move around so much. No,
Here, we're doing it for you. He want no. He. Go ahead.
How about now?
That's right.
Thank you.
Okay, hear me now.
Okay.
Where were we? We
You were talking
somewhere
about putting
around there.
things together from.
Yeah, okay. So we can do this at the moon pretty well. And now it's expensive to land things. It's expensive to build things. And we've already been there, we in the United States, and we know a lot about it. So let's help the other nations. Worst thing we could do is compete. We don't want to compete.
So, is that going to happen? Do we need to get everybody on Earth to work together to make this happen? Because the moon, this is a little history, but the moon launch was propelled by antagonism, that we wanted to go first.
It was, yeah, it happened to end up that the president saw Germans put the V2 up. We didn't do that. Then Sputnik. We didn't do that. But we need to improve things. We can't send a B-29 up there.
No.
It's not a rocket. So we got to build rockets and catch up. So it was a technical challenge for us. Now, how do we know whether we're doing the right thing? Whether we're moving fast enough? Are we beating the other guys? Yeah, so it's kind of a yardstick. It's a competition. And we later, after that, did a mission together with them.
Yep, that's true.
And
Hey
that's
guys,
helped.
there's a couple microphones here, and I know we don't have a whole lot of time left, but if somebody has a question for Buzz, there's a microphone there and a microphone there, and you're welcome to come up and answer a question or ask a question. Or if you want to ask me a question, I have lots of interesting stories. I'm just kidding. And wave at me because I can't see you. All right, here comes someone.
Hi, my name is Xander, and I have a question. You go to Mars, but can you go to Saturn?
Saturn. Can we go to Saturn?
Yes.
Hard to step down on
Takes a
Saturn.
long time to get there. and its gravity is big. And besides that, it's gas. It's not a good place to visit. It's got moons. Might be good to go to those, but they're a long ways away.
Yep. Pretty interesting moons, too. Anybody else?
I do.
Right over here. You have to go to the microphone, I'm afraid. Yes, go ahead so we can hear you.
Buzz Aldrin, how would curiosity or opportunity withstand sandstorms?
Sandstorms. What are we going to have to, we have to worry about those, don't we, on
Yes,
Mars?
we do. Yes, we do. Sandstorms happen in the winter. I remember. In the south part of Mars. And the winter doesn't last 3 months as it does here. It lasts 6 or 7 months. And we need to know when it's winters, when the sandstorms might come.
But what do you do? Just get out of the way?
I'm working on a calendar
I see, okay.
and a watch that people can communicate back and forth.
Okay. Well, maybe one quick question from this side. Go ahead.
Would you go to the moon again if you wanted to?
I don't want to. I've been there.
Been there, done that. Well, that's a perfect place to stop, I'm afraid.
No. I am doing things that, to me and to others, listen to me, are much more important to the future of the nation and I think the world by pioneering things we can do at Mars instead of going to the moon and back.
There you go. Thank you very much, everyone, for coming. There's going to be a signing later. Very nice to talk to you.
Okay. I think we still have people coming inside, but thank you so much for coming back. Buzz filled in for someone else who had a cancellation, but thankfully that gave all of you an opportunity to come and see him again. These people kind of like you, Buzz.
I really hate to be the one that causes you to be after school, because I never wanted to be held back to be after school. But we are, and you are, and we're going to have fun.
We are going to have fun. So I'm going to introduce myself because I was not here earlier today. We had Joe Palca from NPR who introduced Buzz before. My name is Christina Korp. I am Buzz's mission director. It says mission control director on my card, but his son Andy says I have no control, so mission director is more accurate.
Nobody does.
Nobody does, I know. So occasionally I do these Q&As with him because I know him really, really well, and I know how to cut him off when he's going too long. But today I'm going to try to let him talk a little bit without cutting him off too much. We are here to promote Welcome to Mars. And I hope that if you have gotten your copy that you got a chance to get it signed today. And if you have not, you'll get another opportunity if you want. We're going to be at Fort Belvoir tomorrow. And then on Monday, Labor Day, we will be at the Air and Space Museum, the Smithsonian Air and Space Museum. So, but we're still here, and we're going to talk a little bit to Buzz right now. I'm going to ask him a couple of questions or introduce a couple of slides first, and then we'll let some of the kids ask him some questions. I've heard the kids have prepared some questions for him, and I always like kids' questions. But the first thing I'd like to do is show a slide. If you could put this slide up. Okay. Buzz, pay attention. All right, he can't see the screen, but I'm going to... So I would like to know, does anybody know who that is on the screen? See, the kids know. I heard people say Neil Armstrong. That is Buzz Aldrin on the moon. It's one of the most famous photos in history, and most people think it's Neil Armstrong because it's from Apollo 11, but what a lot of people don't realize is that Neil had the camera. And Buzz had to set up all the experiments, so almost all of the photos from Apollo 11 are actually Buzz Aldrin. So Buzz, why don't you tell us about the visor photo? No, you
Can they
can't
see
see it
it?
very
Oh.
well. They can see it. It's over there.
Neil had the camera, he was doing something, and I was walking toward the lunar module on the back side, and you can see the picture that was taken just before. And Neil said, "Hey, look this way." I looked this way, and he took the picture. It was not posed, it was not thought about ahead of time. It just ended up being such an iconic picture. Now I know that my hand looks a little funny, and there's this thing that was swinging a little bit, but the camera caught it where. And I've been to places where Hollywood would look at certain pictures that have been taken, and they wanted to evaluate what was so significant about this picture that is being used. It was me. It wasn't Neil. And they asked me, "Well, what caused this picture to be so famous?" I've got 3 words: location, location, location.
I love that line. So before he went up in Apollo 11, though, he was in Gemini 12. That was his first space flight with Jim Lovell, who was the commander for Apollo 13. And so Buzz was actually the first astronaut to successfully do a spacewalk, being outside of the spacecraft floating around. And this next photo has become very famous. And why don't you tell them a little bit about this photo?
The spacewalking had not been too successful, so coming up on this last opportunity, some fellows who had been doing some research on maybe helping out with the problem, they were part of a school in Baltimore, and they suggested maybe if you were underwater, training underwater, that the neutral buoyancy might be a way that you could use to train before a spacewalk. Now, a couple of the astronauts said, "No, that just isn't going to work." Now, I had been a scuba diver for almost 10 years before, and I just knew what a wonderful idea this was. So I became the first astronaut to train underwater, and it really did what I expected it would do. And because of the success that we had, even though they canceled the maneuvering unit, which I really did want to, I wanted to be like George Clooney. You know, he went, but that didn't happen.
Focus.
Now, there was one spacewalk that was taking pictures of the stars, ultraviolet pictures at night. So Jim Lovell, the commander, would move the spacecraft to point in the right direction. The hatch was open. I was standing on the seat looking out because there was a camera mounted behind me that we didn't want it to go through the window because the window would have disturbed the ultraviolet light that they were trying to take pictures of. So he pointed the right direction, shut off the thrusters so they wouldn't fire during the 5 seconds, 10 seconds, whatever it was. So we took several, one the first night, and then we had a time when the spacecraft was in the sun. Of the total 90 minutes, there's about 50 minutes in daylight and about 40 minutes in darkness. So when we came into daylight, we really didn't have specific things to do. But there was the Earth down there, and I got to really sightsee and look at things. I could see the Astrodome in Houston, look down. And I got this camera here that's pointed out. And I thought, why don't I just take a picture of myself? and that's that picture.
So what are we calling that now?
No, somebody else started calling it.
No, I did. Go ahead.
And then somebody who was...
Well, someone was at the International Space Station, and they took a selfie in space, and they said, first selfie in space. And I was like, what? And then, what is that?
That is a selfie. The photographer was just not too well schooled in the lighting that was needed. No, it was really the ultraviolet. That's the problem.
That was the first selfie in space. 1966. I remember last year you did an interview and you were saying, I didn't know I was pioneering the selfie.
And my selfies haven't improved too much. Because somebody else is always holding the camera.
So obviously, Buzz, he's had quite an extraordinary life, and I like to remind kids that, believe it or not, he was a kid once, too. Actually, he's still a kid. He's a big kid. And, yep, see? Look at those socks. He's very patriotic socks, or else he usually wears space socks. Yep. So, but these days, he sleeps, breathes, eats, dreams Mars. Mars is his passion. I mean, every day. Just before here, I had to drag him out of the lunchroom or wherever we were because he was talking Mars to somebody. So this book is for the next generation of Generation Mars. That's you kids down there. And so we're going to talk a little bit about Mars. So who would go to Mars? Anybody in this room? Yeah,
you guys might go. They're going to be too old back there.
Well, unless they, want to retire on Mars, you never know. So realistically, Buzz, when do you think we're going to get to Mars?
NASA has put out 2030. I don't think we can do the things that are necessary to build up to be able to do that. A lot of people a lot of companies who prepare missions to submit that this is what they think NASA should do. And they pick a particular time when the Earth is catching up, and that's called conjunction, or it's a period.
Keep it for the kids.
The
Come
next
on, not too
time
complicated.
It happens is Earth does 2 orbits and Mars only does 1. So Earth is trying to catch up with it again. And 2 more months, or 24 plus 2. You know what that is. That's 26. 26 months is the ideal time. And if you pick a time and then other companies decide what is needed to send to Mars for that particular time, then they're going to go and the crew is going to land and stay there until the next opportunity to come back. And they're going to take things with them so that they can come back. And that means they're going to stay for a year and a half and then come back.
But what year? We don't have 2 hours.
I think that they're being a little too ambitious, because what we want to do is to put a lot of modules, a lot of living quarters, the same living quarters that we put on the moon and brought together will do that sort of thing on Mars. But the time is very valuable for the people who go to the moon of Mars to put the final accurate connections. From Earth, we can start 6 years ahead and land, and then Earth can move them, taking time, because they're not in any hurry, and we know that things take a lot more time transmitting from Earth.
Well, let's put it this way. So the 50th anniversary.
2040. It's also
Well, but remember, 2019 is the 50th anniversary of
Yeah.
your moon landing.
So, President Kennedy said, I believe this nation should commit itself to land within 1 decade to land a man on the moon and bring it back. Mars is a little more difficult. But within 2 decades of 2019, the 50th anniversary, the Apollo Golden Legacy, the president could say, I think America should lead all the other nations and land on the moon within
On Mars.
They both begin with M, don't they? Okay. It's
Well, one thing that a lot of people don't know is that Buzz has thought about this for a long time. There's a thing called an Aldrin cycler, which is a spacecraft system that he has developed. So why don't you just tell us very quickly a little bit about what the Aldrin cycler is, when you came up with it, and then I do want to take some questions from the kids because we don't have a ton of time. So,
well, we went to the moon 6 times out of 7. That's a pretty good record. And a lot of people felt that we needed to get through with this shuttle time and then move back to exploration. And I thought that, well, the moon, we can take the orbit that we go to the moon, and it is a free return, so it goes around the moon and comes back to Earth. Now, if it doesn't stop, it'll go around the Earth and go back out again. So there's the possibility that something can just keep going back and forth. It's much more involved than that, but it's very, very doable. And it's not that good if you're going to land somebody on the moon from the Earth. What we did is probably the really best way to do that in Apollo. But if you want tourists to swing by the moon and then come back and see what the moon looks like up real close, you can put tourists in this. And that was the reason that I was submitting this to NASA. I'm very disappointed when they said, we just don't see a use for this. So I was encouraged by somebody, maybe you ought to look at Mars with this gravity assist where you approach something and you don't just go straight by, because whatever it is wants to attract it. So you bend the orbit a little bit and you can control this to come back to where you want to be. So this administrator in NASA said, well, why don't you use your gravity assist that I was going to use at the moon and at the Earth? Why don't you do that between Mars and Earth? And I thought, wow, that is really difficult. But it wasn't, because the Earth has got 2 spacecraft going around it, and one's going to catch up and join up to the other one. Now we got the sun, and Mars is going around the sun, and the Earth's going around inside. Same problem. The numbers are quite a bit bigger, and takes longer to do things. And so I devised a way that, yeah, you could swing by Mars, leaving Earth in about 5 months, and then 21 months later would make 26 months. You come by the Earth and you do it again, and you just keep doing that.
And this is in the book. This is actually in this book, and you'll learn more about it. If you read it, then the reason I'm stopping you, Buzz, because we got less than 10 minutes, and I want to take some questions from some of the kids.
Yep.
So if you're a kid and you got a question, there's some microphones right here. And so I'd like the kids to quick, and Buzz, try to keep your answers short so we can get more than a couple of questions.
Now, you have to understand the cycler is supplying the crew what it needs, and it keeps coming back. It's reusable. So all you need is to intercept it with a lander, or 2 landers, or 3 landers.
And maybe one of these kids will help you do that. So let's take this young man right here first. He's waiting very patiently.
Okay.
Get real close to the microphone.
Okay, so Buzz, how old were you when you first went to the moon?
How old were you?
39. All of us on Apollo 11 were born in 1930. I was the oldest.
So you got lots of time. Let's do this young lady over here.
How old were you when you realized that you wanted to be an astronaut?
Oh, what?
How old were you when you realized you wanted to be an astronaut?
29. I was in Germany, a fighter pilot, and we were on alert with nuclear weapons.
Don't
if
go down
needed.
that road.
And Life magazine came out, and it showed this capsule and this rocket and talked about the people who might fly them in the Mercury program. But they had to be test pilots. I hadn't thought that I wanted to do that. I wanted more advanced things to do, so I didn't. Okay,
But you didn't give up.
Here I did. Here. No, I went to MIT, and in 1962, a good friend of mine, Ed White, he was rather later killed in the Apollo fire, but he was a good friend from West Point and also that squadron in Germany. And we talked, and he said, NASA wants some more astronauts. In 1962, he says, I'm qualified. I've been to Michigan. I've been to test pilot school. I'm testing airplanes. So he said, I'm going to apply. And I said, well, Ed, I can shoot gunnery better than you can. So I'll apply too, because I'm doing some interesting things of joining up spacecraft like a fighter
Okay,
joins
keep
up.
going.
So I applied and was turned down. He was picked. So I started working at MIT on joining a spacecraft together. So when I applied in 1963, NASA knew what I was doing. I'd been telling them what I was doing. And I was selected in 1963.
And then they picked him that time. So kids, try again. If at first you don't succeed. Okay, let's go to this young man right here.
Who made the biggest difference in your life?
Say that again.
Who made the biggest difference in your life?
What made the biggest difference? Who? Who made the biggest difference? Quickly.
My father was a very early pioneer, and he knew a lot of people. He knew Orville Wright. He knew Charles Lindbergh and Jimmy Doolittle, who bombed Tokyo.
Ixnay on the bomb.
They bombed us first.
Okay, but quickly because we're almost out of time, Buzz. So Jimmy Doolittle, right?
Yes.
That was his very influential
Now,
person.
he was a role model that you'd be real hard to find a better role model.
Okay, this young lady over here, actually, she wants to interview you, but go on.
Can you describe what it was like taking off in that Saturn V rocket? Because that's one of the most powerful rockets.
The Saturn V had 3 different stages. And the first one, when those engines lit, we could tell by the countdown and we could tell by the instruments, but we really didn't feel like we were going anywhere. We talked to each other about this afterward, and we felt that at T0, we were no longer attached to the Earth. We were on the way. We could see we were moving out the window. But there wasn't a lot of shaking as there was in the shuttle. And as we accelerated, we started getting pushed back in the couch. And the fuel economy was not so good in the Saturn.
What was it?
7, yeah,
Go on.
not
7.
30 miles to the gallon. 7 inches to the gallon.
Okay, we're going to take this young lady here. We're almost out of time, so we got 2 minutes.
How did it feel to
Sure.
be one of the first people on the moon?
How did it feel to be one of the first people on the moon?
Very lucky, very fortunate. Without going into the details, the spacecraft that we had originally was too heavy to have landed. But the weight was reduced, and so instead of October and Apollo 12, it was July and Apollo 11.
Wonderful.
Very lucky.
One more. This young man right here.
Okay.
Or is that a girl? I can't
It's
see.
a
It's a
girl.
girl. Sorry. It's bright lights. Go on.
What gave you the inspiration to write your book, Welcome to Mars?
Because, the inspiration for me, I found a successful, a very good transportation way. So I shifted my interest in the moon and developed things, how we could do Mars. And then I went back, how can we prepare at the moon without spending too much money by learning how to do
That
the
was
thing.
Mission to Mars, though. Why for kids?
Because if you're about 10 years old, in 2040, that's 2 decades after 50th anniversary, you're going to be 35 years old. And that's just the ideal time to go to Mars.
Because you guys are Generation Mars. That's why.
This has been a presentation of the Library of Congress. Visit us at loc.gov.